Continuing on with our discussion of domain and range, let's take a look at this function here. As I mentioned before, this is what we know as a step function, and let's label our x and y axes. Domain has to do with our x activity, and range has to do with our y activity. Taking a look at domain first, we always want to look at what's going on as we move from left to right on our graph. What's our smallest value of x, if there is such a thing, and what's our largest value of x. So as we start negative x territory and we move along our graph, we see that the first x value that we encounter is this point here. And so in order to figure out what that point is, we have to look down, or the x information, I should say, of that point, we have to look down to our x-axis here. And we see that x is -2. So our domain is going to start here at -2, and we're going to use the bracket because it's a closed circle. That point is included. So we move along towards the right, and then we see that we have this point here. X is 0. So when x is 0, we have an open circle that would look to say that that point is not included in our domain. But looking up just a little bit at the next step, we see a closed circle, so x is 0 is okay. That would be included in our domain. Continuing along, we come to the next value here, open circle. Looking down at our x-axis, that looks to say at x is equal to 2, we wouldn't include 2 in our domain, but again, just above it is a closed circle that says, nope, 2 is indeed in our domain. Continuing on, we reach the final point on our graph, on our function. Looking down to our x-axis, because we need to identify the x piece of information in this point, and we see here that the value is 4. So we have 4 as our ending point on our domain. Now, I put bracket here, but if we look at this point, open circle, that says that the 4 is not included. So this would not be a bracket. It ends, but it would be parentheses because it ends at the 4, but the 4 isn't included. Now let's consider our range, our behavior along y-axis, which is an up and down behavior. And this is kind of interesting in a step function because this range is going to be made up of discrete values. What I mean by that is if we take a quick look back at this other example, we can see as we moved along our graph here, there were no jumps, there were no gaps. We move from points and everything in between was included. By that, what I mean here is that y is here about -1. And then we move to y being 0. Because this is a solid line, all the values in between -1 and 0 for y would be included. So here, this would be, I don't know, -0.8. Here, maybe -0.75, -0.699, -6.5. My point is all values, all fraction decimal values in between would be included. Going back to our step function, because this is a step function, by definition, we jump from one value to the next. So our range here is not going to be an interval, it's going to be specific values of y. So the first one we have here is y is 1. And the notation I'm going to use here are these curly Q brackets. I don't know the exact formal name, I'm calling them curly Q brackets. So we have y is 1. We don't include 1.5, we don't include 1.25, we jump to the next value of y, which is 2, and then we jump again to y is 3. So to repeat, this is not an interval. This doesn't say our range goes from 1 to 3. It says our range goes, it's 1, it's 2, or it's 3. Now let's take a look at our intercepts. For our x-intercepts, when we look at this, there's no place where our graph either crosses through or touches our x-intercept. So there are none. There's no x-intercepts. In regards to y, it looks like there's potentially 2. However, when we look closer at this value here, where y is 1, we see it's an open circle. That point isn't included on our graph, so there is no intercept here. However, when y is 2, we do have a closed circle, so that is a y-intercept. Now let's take a look at this particular example here. We're going to learn to recognize that this is a polynomial function later on in the course. For now, we're just going to look at range and domain. And first thing, my clip art did not cooperate, so please put the little arrows on your graph to show that this goes on forever. And again, let's identify x and y axes. Domain, x behavior. So starting looking for a smallest value that x could take on in negative x territory here, starting on the left, we see that we have an arrow that says that our x is going to continue to get smaller and smaller indefinitely. So we don't have a specific beginning point, so our domain is going to go from negative infinity. And now looking at the right side of behavior in positive x territory, we see that x gets bigger, and then again, this arrow says here, x is going to continue to get bigger and bigger indefinitely, if I can spit those words out. Now, range has to do with y behavior. What's happening with y? So coming from negative y territory, we see there's nothing down here. And in both negative and positive territory, for x's at least, we see that the smallest value that we encounter, the first point we encounter on our graph, is here in both cases. So we have to go back to our y-axis here to determine, because range is all about y, what's the y coordinate of these points. So we see here that our range starts at -5, negative 1, 2, 3, 4, 5. So our range starts at -5. I'm going to use brackets. There's no closed circle to say it is specifically brackets. However, it is a solid line which says that that point is, both these points are included. So now we start at -5 and we go up and we go up. Along this part of the graph, we go up. We'll learn to recognize this as a relative max. But then on these branches of our function, we go up and we see these arrows that say that our y values are going to continue to increase indefinitely. So we have our range as positive infinity on the right-hand side. Just want to point out for a minute, just because the domain is negative infinity to positive infinity doesn't mean your range is also going to be negative infinity to positive infinity. It might with some functions, but in this case, our range does have smallest values that our function will never go below. So our range does have a specific beginning value. In terms of x-intercepts, we have a lot going on here. We have 1, 2, 3, 4, 5. So I'm going to take a look at these going from left to right. You don't have to name them that way. That's just how my brain is operating this morning. Looking at this first point here, this value is -6. Our function is slightly beyond that, so it's slightly smaller, but I'm going to approximate it and say our first x-intercept is about -6. We have another one here at -3. We have one here when x is 0. We have one here at 3. And then again in positive territory, here's x is 6. Our intercept is slightly greater than that, but I'm going to approximate it and say that it is 6. Y-intercepts. We just have the one here at 0, and that's something that you might already be familiar with and recognize that whenever you do have an x-intercept of 0, which is the origin, the y-intercept is, you're also going to have a y-intercept there at that origin 0, 0.